Welcome everyone. Today we have our another new episode and we will discuss about industry, the new cobotics issues like how human and robotic can work together. We have our world famous entrepreneurs and world famous speaker, Professor David Smith and Mr. Marshall. I want to start from Professor David Smith. So how you want to analyze this topic and what the opportunity we can bring in the industries through this cobotic robot and human resource.
Cobotics is a real interesting topic, again, like most of yours. The cobotics marketplace, though, is really beginning to grow a lot more with over 40% compound annual growth. Uh, this year, it's projected to be about $1.2 billion in its market size, and by 2027, it should reach almost $11 billion in market. And it really is the development of a robotic that is intended for direct human interaction, or where humans and the robotics are in close space working together to do activities, as opposed to where robots are isolated from human contact. You know, a great example of an isolated robot is if you go into most of the automobile manufacturing lines today. You have robots that are controlled way back from a control room, which they're already automated. And the only reason the controller is staying back there is in case something goes wrong. You have other robots, and to me, a great example of a cobot is some of the robots that you see, for example, in Amazon warehouses, where they will go and pull the bins up, working with the human, bring the bin to the human, take it back, and doing all that type of activities. And that is what has allowed, for example, Amazon to scale as much of it as it has. Uh, Cobotics really were impacted by the start of COVID, but as COVID has gone on, it actually has pushed more of a surge in it. One of the largest markets, though, for this type of collaborative robot is in the Asian Pacific Rim, and particularly around China. And you see many of those robots, though, coming from places like Switzerland, Japan, Germany, Japan, and really beginning to push it there. Uh, the logistic challenge we're having today is one of the elements that is going to push even more growth into this area of these collaborative robots. And it's a very interesting one. The cost to uh, uh, deploy these in many instances is costing more than the price of the robot. And you see that as one of this because of the human factors that have to be put into place to do this. There's a lot of opportunities, there's a lot of challenges, there's some restraints going on. But as we talk more in the show, I'm sure we'll begin to get deeper into those things. But I think this isn't a bad high level intro.
Thank you. Mr. Marshall.
Yes. So what I want to talk about is the practical aspects of cobotics. And so we are in the climate restoration, climate repair mission. We take systems, predominantly pyrogenic carbon capture and storage systems, but we also have ultra-fine nano bubble generation systems combined. And we have new technology that converts the output of syngas coming out of pyrolysis into energy with ultra low emissions to zero emissions. One of the things that's important about this is that we want human interaction, but we also need robotics to actually manage the process, because unlike most systems, the largest pyrolytic carbon capture and storage systems you'll find are in Finland, Stockholm, Sweden, Mississauga, Canada, and I believe there are 3 in Hunan province in China. And they process 10 metric tons a day, each system, 10 metric tons a day of waste into a material known as biochar. We, on the other hand, are processing 120 metric tons a day out of one system into 30 metric tons of char. That volumetric increase, which is exponential, obviously, needs to be managed in a precise manner. Moisture content is important. The output is important. If you process into a low moisture content char, you have the risk of explosions and things like that. So robotics play a heavy role, but you want human interaction to manage it. In addition, one of the parts that I think fits right well with us with this technology is by employing cobotics. What we're doing is we're engaging human interaction, and we're paying them decent wages, which is part of our triple bottom line approach. The triple bottom line approach is obviously a good return on investment for the bondholders or the shareholders financially, but more important, a quantitative return on the reduction of environmental impacts. And of course, the third stool of the triple bottom line is social impacts. And of course, human interaction is part of the truth. I mean, we're doing this for humanity. So we want people to have decent jobs, good paying jobs, also interesting capabilities to deliver what they're doing. And we want them engaged in what they're doing. And we believe that interaction between the robots and the humans, which is this topic, it gives a layer of value to the human capital that we're putting into this process, and allows us to create value beyond a commodity approach. So that's where we're coming from.
Thank you. Professor David Smith, like one thing, this is very interesting for me. Example, developing nations, they have many people, especially they have youth. Developed nations, I believe that some countries, maybe they have negative growth, like Japan, like Germany, they have negative growth. So I'm just trying to learn from both of you. Maybe these robots and artificial intelligence and this kind of human and robotic interactions is more applicable, example, developed nations or in the developed worlds. Do you believe that developing nation needs same kind of approach, same kind of economic or policy or strategy? Because try to understand, they have huge amount of people in a small country. They have 60% around youth. So maybe example, if I take one country, example, Bangladesh, they have 180 million people, 90 million youth. They have a lot of pressures for creating job opportunity for youth. If robot comes, maybe young people, they do not get a lot of job opportunity. Something we want some realistic strategy. What do you think?
Well, a lot of it depends on the vertical, the industry where you're putting these collaborative robots into, and what it is. You know, one of the early uses of the collaborative robots was really looking at how do I pick parts, pick items, how do I place them, how do I load and unload, how do I palletize, how do I package, and how do I do that within the flow within the operation. Some of the places you're seeing cobots today really go into is, for example, in healthcare. Uh, One of the leaders of this in the healthcare domain is in Japan. And what you're seeing there is in Japan and China, you're seeing cobots there used to, for example, uh, go down the hallway in trying to enforce face mask and social distance. You see many of the cobots being used to spray disinfectant and other elements like that. And you're seeing those. A great example of one of those is one in China, and the collaborative robot is called Ambot, and it's doing that. You see other places in hospitals, and now going much beyond them, where they're doing thermal screening to see if people have a temperature and thing as you begin to enter the facility, work during the day. Uh, and you're seeing a lot of them in that process. Uh, I was surprised a couple of years ago that this type of cobot has become so sophisticated that they can actually begin to not only measure your skin temperature to see if you have a fever, but they can measure breathing rates, pulse rates, blood oxygen, other elements like that. So they're beginning to move into that type of work. But where a collaborative robot is different from a traditional industrial robot, like the ones you see in automobile manufacturing, airplane manufacturing, others, is how much they can lift. Uh, the cobots today are really working with items where probably 10 to 15 kilograms are their maximum range. Their arms are smaller. They can't do it. There's has to be more of a safety zone with them because of their interaction around humans and like that than you see in a classic industrial robot. When I go through like a General Motors assembly line or a Boeing assembly line, their big industrial robots have fences around them. They have areas around them that you as a human cannot cross unless the robot is totally turned off and disconnected. Where you see the same type of operations where the cobots are actually bringing stuff to restock the assembly line, bringing the logistics, and that's an opportunity in many places. Where the cost of human capital is low, some of the type of activities you see cobots doing can be done by humans just as easily. Uh, on the other hand, humans like to take breaks and stuff. You don't see that in the cobots really, so you see these other things. But the one place where, particularly in developing nations, where I think you're going to see a lot of this growth is in places where the environment has hazards. So today in nuclear plants, for example, cobots are really in active use there because of the potential of exposure to radiation. You're seeing them used in some of the semiconductor facilities because of the exposure to chemicals and vapors used during the process, which are pretty dangerous. So again, different places and each use case is different. And I see the same use cases in developing nations where, yes, because there's a lot of low cost labor, you can use it for that. But I still don't want to put a human at risk in places where the risks are high, and I can use a cobot instead. Does that answer your question?
Yeah, yeah, definitely,
I
definitely.
think it
This answer.
really is that easy. It depends on the applications.
Yes, yes. Thank you, Mr. Marshall. I know that you are developing many interesting projects. So, what do you think? Uh, yes, how the
So
developing
my
nations? Yes, please.
right. So I think that the topic is I think what David talked about applies directly to our use case. So we have joint ventures around the world, and what we're doing is we're taking what is typically considered waste, and a lot of waste is considered dangerous to humans, or could be with pathogens and all sorts of chemicals in them. And with robotics that are in conjunction with humans, we lower the risk to humans, increase the safety, but at the same time, we get a deliverable that is available to people that are, where they can actually operate in the environment. And I noticed that David talked about the fact that maybe one of the issues is that the robots are continuously operating. They don't need a break. Humans need breaks, but actually, we think, in our opinion, that the break is good for the humans because what it does, humans are much more efficient when they're rested, and we want that rest. It's part of the mix. It's part of the reality. So our approach is to integrate a real concept of not trying to turn something on its head, but actually take advantage of what people might consider weaknesses and turn them into strengths, which are internal to our organization. But by the same token, we are, by using the human robot interaction, we get great opportunity to increase the quality of what we're doing, improve the deliverability, and turn around and meet our mission, which is climate restoration and climate repair through these joint ventures by turning waste into resource. And these resources in and of themselves actually reduce environmental impacts. But in our use case, that is really extremely important. And we see as the human robotic interaction as an ideal situation, not something that we have to accommodate. We see it as something that we use. Plus, in addition to that, we are integrating this technology together with other technologies that allow us. In a previous session, we had one on AR, and we're using AR so that management around the world can keep an eye on what's going on. But at the same time, if a manager is not there, he has to go someplace, he still can use his phone using AR to see what's going on, watching the robots, watching the human interaction, and help. If there's a blockage or a downtime, he can get back in time to help fix that. In addition to that, we're also using the same technology that blockchain technology to keep track of inventory, both the waste that's coming in and the material that's going out. And in our case, that would be biochar, it would be syngas and thermal energy. And the robots deal with that, but the humans manage it. So we're using humans as management, and we're using the robots not as labor per se, but as a mechanism to manage dangerous processes, which these are. And we acknowledge it. But what it does is it lowers risk. And when you lower risk, you're increasing opportunity for both our employees, for our customers, and also for our joint venture partners and for society as a whole. So that's why we, in our use case, I totally agree with David. We're kind of similar to the medical industry that he brought up, and we're also similar to some of the use cases that he talked about. I see us as a use case that other people can emulate.
Thank you, Professor David Smith. Another things, I just want to share one of the case study with you. Uh, uh, in developing nations, with one of the automated company, we go for waste management, and I find that if we introduce these automations, definitely waste management actually definitely unhealthy things. Many things actually engage with waste management things. But when we go there, we find that if we introduce automations, then around 3,000 people go for unemployed. And second things, it will be big burden for politicians, and it's practicals. When developing nations, income is not so high, they do not have social securities, and job creation also very difficult. So in that situations, what will be the best approach? Like as a consultant, I know that you are engaged with many developing nations. As a consultant, what you will guide uh, this kind of initiative, or what you will guide the policymakers especially?
Well, particularly on the policy side, I want to tell you that the base problem that you're asking in your question is not unique to developing nations. You have the same thing, for example, here in the United States. So the concept that we really need to get instilled today through the government, through individuals, and even through academia is we're in a time where the concept of lifelong learning is never more important than it is today. If I'm a person who worked on an assembly line and my job is supplemented or replaced by an industrial robot or a cobot, part of what I want to do is I want to be the person who goes and sets and controls it. One of the persons who can help program it, one of the persons who begins to look and multiply what I can do across multiple of them. So it becomes a higher paying job. Uh, there's places because you were so intense in the, for example, an assembly line, where you have knowledge about the processes that very often some of the folks outside that environment do not have. So, but the key to it is you have to do lifelong learning. Right? It's just like I said in some of the software shows. My developers are constantly taking online courses. They're going to boot camps, either online or in person, and they understand the concept of lifelong learning. Uh, Today, with regenerative healthcare, it's estimated that a person leaving high school today, by the time they leave their uh, time where they're working, they're going to go through over 30 career changes
Mhm.
today. Where back when I was in high school, you may be looking at 2 or 3 career changes. And that's one of the big changes. But the governments need to embrace the concept that's lifelong learning, and universities have to embrace that, because universities are still in the mode. I'm going to give you a bachelor degree, a master's degree, a PhD. And when you're in lifelong learning, you don't have to go and sit in a classroom for 4 years to begin to learn the new skills required to move forward. So we have to begin to look at, even for universities and colleges, we have to adapt the model to be more applicable to this concept of lifelong learning. And that's the key to accomplishing what you're talking about. Is it's just like when we went from using rocks to farm with, to using metal instruments, to using animals to pull the plow and stuff, to using tractors, and now autonomous tractors. All those times people were displaced because they didn't want to learn how to use the next stuff. They didn't want to learn how to leapfrog. So this is a problem that goes back hundreds and hundreds of years. Uh, and it's one that we should learn from, but it's hard to change institutions, and academia and governments are 2 of the largest institutions.
Thank you, Mr. Marshall. You are also from industry. I always welcome, even in my classroom, I always welcome industry people, because yes, I am academicians, but industry people can share a lot more interesting things with young people and the youth communities, and they can learn. So always, even I request the academy that you should go for 50-50, at least 50% faculty come from industry, 50% from academician, then maybe classroom will be more interesting. Definitely we will share our content with our youth communities, with our students. So when you develop a project, example, I know that you have a very successful corporations. So how you develop human resource plan, recruitment plan, and how you make plan for modern technology like robotics and these kind of things, because from your experience, if you share, I think it will be more interesting for our audience.
Well, thank you, Sharif. The approach that we use is a method that is deliberate. Obviously, it is planned. We just don't do things ad hoc. Sometimes you need ad hoc approach to life, but we find that when you're dealing with our mission, which again, climate restoration and climate repair, it's a big mission, and you need what we say, and I think we heard this at COP26. We need all hands on deck. Even people that may consider themselves our competitors, we're ready, willing, and able to reach out to them to collaborate. Our approach is a collaborative approach. There is a book called Sacred Economics, which talks about economics that is different than what we've developed over the last 100 years. Right now, we have a competitive marketplace in which it's a win-lose situation. sacred economics poses something different, that it doesn't have to be scarcity. One of the things that we talk about in developing people is that it ties directly to the fact that our systems, both in the developing world and in the industrial world, are tied around the concept of scarcity. But I give an example. Here in the United States, 40% of the food that is grown is ultimately thrown out. It doesn't need to be that way. It's crafted on a structure that presupposes that profit is king and nothing else. That's why we've taken a triple bottom line approach of equal importance of people, profits, and planet. And so your question goes to the third leg of the stool, people. How do you develop people so that they are even in all across the world, whether it's in the developed United States or Western Europe, or even underdeveloped countries that are struggling to bring people into educational levels and also job security that they need. I think that this type of approach integrates the cobots with the cobot approach, which is integration of people and robots together, and allowing the management of the robots by the people, because people have brains, they have gray cells. Those gray cells are much more valuable than a robot coding program. Now, it's true that some robots can process something that's very dangerous and much easier and lift heavier items. That's to our advantage. But it takes human knowledge and human interaction, and we want to foster that no matter who our employees are. So I'll give you an example. The original triple bottom line approach was developed by a professor out of Purdue University back in the 1990s. His concept was that you have a good return on investment, you have a good lowering of environmental impacts, and they're all quantitative. His third component was you have good paying jobs. That's what he meant by a social impact. We've increased that. The increase of that is that we've gone beyond not just paying well to people, but also allowing them to get an education, and we'll pay for that out of our joint ventures. Why? In the beginning, well, why? Because we need educated people. Educated people allow society to create greater opportunities, more democracy, more sharing of opportunities as well as risk. And one of the things that we're doing is we said in the beginning, oh, well, we're going to need a forestry management guy. So we'll pay for a forestry management Bachelor of Arts degree or Bachelor of Science. Or we're going to need a civil engineer. So we'll pay for that. Then we woke up one day and we realized it doesn't matter what degree they want. Why should we tell people what they need to study? Let them study English literature for all we care, as long as they're happy. But we are fostering in them their needs. It's about a different perspective on human capital. Human capital is the most valuable capital out there, more valuable than the money. And it's human capital that will make this earth recover from the devastation of the climate crisis that people were talking about at COP26, but will also allow us to engender and make the world safer for our children and our grandchildren. Hopefully that's a good answer for you.
Definitely,
and for the audience.
very good answer. Professor David Smith, you are also an entrepreneur. I also love to learn from you, and our audience has many questions. I will take their questions, but what is your answer? How you develop, example, human resources strategy, AI and technology-oriented strategy inside organizations? It may be helpful for our youth communities in developing world.
Sure. One of the key elements in cobotics is that it allows the company, the persons using it, to combine the capabilities of a robot, which really are the strength, the precision, the repeatability of it, with the people's, the humans' explicit skills. What is the know-how? What is the analysis I can do? What is the decision making that I can do to really add that to what we're doing collaboratively with a robot? So you can see there's still a dichotomy there as you're working together and doing those. What is also interesting to me is I got an email yesterday. The that, as you know, I'm on the investment committee of the International Accelerator here. And we have a meeting coming up in a couple of weeks to look at new people to admit to the International Accelerator. And one of them is a cobotics company. And it is, let me switch over and look at my email real quick. It's out of Kakistan, and beginning to see it. Just looking at some of the early application data from them, they're a very small company. They have 4 people in the company, and they have a product that looks like it has a lot of applicability in multiple industries. And they're not exactly from one of the top 5 nations either. So the ability to go and do that type of development and that type of activity is only limited by the domain knowledge you have first, and the ability to reach out and find who to collaborate with, who to buy products from that you can enhance with your application know-how. And so the ability to look particularly in public-private partnerships where you can leverage the risk of training with a standard set of software that's in robotics, like Tensor, a solid set of hardware that's applicable. The hardest thing in most cobotics and the hardest thing in most industrial robots is, how do you program the arm? How do you work with the arm? In cobots, the arms are smaller. So once again, it's a place where innovation can come out and shine and be applicable, and domain knowledge gives you the leg up as you begin to apply cobotics in new domains where they haven't been used before. One of the other examples I saw with cobotics is actually in the food services industry. You're beginning to see cobotics used to, for example, wash the dishes. You're seeing it begin to use for simple assembly of materials, the ingredients before it is actually cooked. And so, again, you're seeing them in industries that are very broad and scattered. It's not just the top ones like aerospace, automobiles, healthcare. It can be used in many, many activities. I would love to have one here at my house to help my son pick up dishes around his room and around the kitchen that he just doesn't do. And a cobotic with him doing that with a small articulator arm, and that would go and remind him or even get him out of bed to do it, I would pay money for that.
Thank you, Mr. Marshall. There are a few questions from audience. I want to take few questions. Alea, why cobots are significant in developed countries? From Alea.
Oh, that's a great question. Both in development and non-developed countries, cobotics plays a greater role. We can't ignore technology. We can't ignore advancements. We have to integrate them into humanity and make it so that the human value is improved. By the way, David, I want to let you know that I had a Zen moment when you said your son has to have a cobot to pick up the dishes. Actually, I get a Zen moment when I wash the dishes, but I'm a little different than most people. They don't like to wash dishes, but I love washing dishes. But anyway, going back to the actual question, that was just a little humor there, hopefully. It's a serious question. We need to understand that as human populations grow, there's more tasks that are going on. Now, I'm going to go back to my use case because that's something that I'm familiar with. One of the things that we do in our systems is we feed what we call the feedstock, which is waste, and there can be all kinds of waste. It can be municipal solid waste, which is mixed waste from what people throw out in the garbage. It can be textiles, plastics, organic food waste matter. Or you can go to a sewage treatment plant and you can take the sludge that is processed there and you can convert that into a valuable material known as biochar for different markets. The issue, though, is when you're taking this material physically, you're putting it on and I forget what the acronym stands for, but it's called a MRF, and an MRF. And a MRF actually is a chain that it's like a drive that allows you to put material on a cable, and it feeds into the machine. Now, in one respect, if it's not fed properly, or if it's not placed properly, it can cause some stoppage and blockage. So what a robot can do is obviously do that, but you want it under the management of a human being so that you have an understanding of the ability, if you need to modify how that happens, because in our case, we do make modifications sometimes on the fly. Well, hopefully not, but sometimes you do need to do that. You've got the human interaction, the human brain power to understand and recognize what's going on. Now, some people say that artificial intelligence will one day be able to make those decisions. That may be the case, but we still believe that it's human interaction that and human decision making that is the paramount decision making process. We don't want to get rid of it. We want to embrace it, and by embracing it, we not only create good paying jobs, but we also get people feeling that they're involved in cleaning up the planet. Even a person that's on the line of our system recognizes, and we have videos of this, recognizes that they are participating in something that's important to humankind and everybody on the planet. So I just want to say that hopefully the answer to the question is it's important in both developed and undeveloped countries because it's human capital that we're improving. And the robots do a job that could be dangerous for humans, but when you take that danger out and that risk out, you get a better output and you get better quality with human interaction. Hopefully that answers the question.
Thank you. Professor David Smith, there is another question from a very basic question, but I think they will love to learn. Mahadi Hassan, good day everyone. What is the difference between robot and cobots?
Well, the biggest difference is industrial robots are much larger, much stronger. They typically are taught to be stationary and work around the objects that are around them. We're seeing that dynamic change a little bit more, particularly since for large scale 3D printing, you're seeing robots begin to being used as part of that. And for example, here in Austin, we are 3D printing a whole community. Every house in it will be 3D printed. And you're going to see the large industrial robots and cobots used there as well, depending on the task that you're doing within that community. Cobots versus industrial robots, the amount of weight it can interact with is one of the big distinctions. Cobots today are about 15 kilograms and below. Industrial robots can go up to massive size to begin to do that. And part of it is as I began to look at some of the industries they're applied for, and that industrial robots have a large set of safety, ISO, other standards it has to meet. Cobots do not have to rise to the same high level of certifications that you see for industrial robots. Most industrial robots, not all, because the paradigm's changing because of AI, are ones that are aimed towards more repetitive processes. Cobots adjust more on the fly. I could be in an Amazon warehouse that all the picking from the floor, all the placing from the floor is done by cobots. Moving that there, it would be dangerous for a human actually to go get on those paths that the cobots are using to do that. I couldn't do that type of go find this, pick this up, go find where this should go, place it there with a classic industrial robot. Uh, Other quick thing to kind of say on this one really is um, we're seeing the market broaden in ways that that we've all been talking about so far this morning. Um, the ability to go and adapt is going to be a very important consideration going forward. But the largest markets today really are looking at how to handle more payload, how to do things faster. Um, the other thing is you compare it to the traditional robot, the industrial robot, which is really driven by productivity, usability, repeatability, safety. The cobots are designed to work side by side with humans. And because of that, and putting more smart vision, more artificial intelligence into it, you'll see it. And cobots really involves a sharing of skills and a duplication of skills that are going forward with it. So that's some of the differences between cobots and larger industrial robots. In some applications, the lines is blurring. For example, in the pharmaceutical industry, uh, cobots are being used now more than the traditional machines to move chemicals in the pharmaceutical process, to load bottles with drugs in the process there. Uh, there's even a company out of Sweden that makes a robot that its sole, a cobot that its sole purpose is to screw the lids on containers. And I can tell you, as a human, I would hate to sit there and screw lids on containers for 8 hours a day. And so you're seeing that as some of the differences there. But again, going back to it, you're seeing different types of robots, whether it's a larger robot or a cobot used also when safety is a concern. And I think that is one of the other differences there too, is large industrial robots don't have as much mobility as cobots have. And so cobots can go places, and for example, in a plastic company, a semiconductor company, go and be part of a search a team, a reaction team to a problem, where people in that industry, like in the semiconductor industry, have to take the time to go and dress up in containment suits. And having done that, I can tell you it's not fast, nor is it pleasant. Where a cobot can go right in and begin that process immediately as the humans come in afterwards to help put their knowledge making, their decision making, their analytics in place to help the cobot work. So I hope that kind of puts some of the distinctions with some examples.
Excellent, excellent. Beside that, as a robot and a human will work together in future, uh, like how different organizations they should adapt the modern technology, especially developing nation. There are many traditional organizations. Many. What do you think?
Marshall, do you want to tackle that one? Do you want me to?
Sure. Well, first of all, I want to have a follow on what David said because he brought up a topic that integrates the current question, the previous question. One of the things that we do besides take waste and convert it into what we call product or a material that helps reduce environmental impacts, One of those is an integration using cobotics with the manufacturing of cement. Today, cement contributes 5% of GHG emissions around the world. I don't know if you know that. And the United States, over the last 200 years, produced a lot of cement, but China, in 5 years, produced more cement than the United States has done in 200 years. And so the question is, how does this process actually integrate with what we're doing? So yes, we're taking waste, we're converting it into this material known as, some people call it biochar, we call it elemental char, and then we formulate it with cement. So one of the things that a robot, like a cobot, can do is it can precisely formulate the mixture. And it's important for us because one of the types of cements that we're creating that goes into concrete is we have a reinforced concrete that is 30% lighter than reinforced concrete, and we have it 100% stronger. So if you're going to build a bridge that is in an area of the world where there's earthquakes or other environmental issues that can affect infrastructure.
I'm sorry about that. I think there is an internet issues. Mr. David Smith, if you want to add some point.
Yeah, I liked where he was going because that is some of the elements you really see there. The classic area of where can developing nations put the pieces together is he's right. One of the countries and companies I've worked with in the past was in Thailand, one of their larger companies called Thai
Sorry
Cement.
about that.
And they're beginning to apply this there too, which is a great example in the Asia Pacific realm of it happening. And in China, you're seeing the same type, and it's there. But Marshall, you were cut off in mid-sentence, so I'm going to let you finish your sentence.
So,
Yes.
and I heard you say Thailand, which is very good. We should talk about Thailand. We've been invited into Thailand to do these types of projects, and so cobotics is important because you're formulating a different feedstock into different outputs, and you need the formulation to get the value, but you also can create, like I said, this concrete that is 100% stronger and 30% lighter than traditional reinforced concrete. It also withstands burning and explosions. And that's important because it's the safety factor. But if it's not formulated, if it's off a minor component, which human interaction might address, if you program the robot to do it just right, but you have human oversight of it, you can get validity and you get the right product into place. And what that does, that gives value to the human capital as well as the robot. And so at the end of the day, we're integrated not just on the production of waste into a raw material for other products, but we're also integrating ourselves into the production process of these other environmental impacts that can, like reduce GHG emissions with cement and manufacturers and people like that. And it's not just that, it's also other areas. So we also formulate a char that is for animal husbandry char that reduces the mortality rate of livestock by a minimum of 50%. But if it's not formulated correctly, it's no good. So the robot plays an integral role in getting precision along with AI, but you have the human interaction to ensure that the quality is there and that you've got some value of the human brain. We believe the gray cells of the human are far superior no matter what you get from a robot. In fact, who develops the robots? Humans. So, and also other robots. but actually, at the end of the day, this is what's going on. And I got back on, I heard about Thailand. We've just been invited into Thailand to take waste there and convert it into different products. So I think that's an example of another country where there is a lot of waste. It's polluting water, it's polluting soil, and we can turn that around. And that's the mission that we're doing. But I like what David is talking about in terms of these other use cases. And I think the more we broaden our perspective on those use cases, the more our team will be able to have a better understanding of how best to use these technologies as they develop over time.
Thank you. Thank you. This is really great session, and especially for our youth. Second things like example, I just want to know because just last week I do discuss with my people. I'm from a country in South Asia, so I discuss with the people because in my childhood I learned a lot of things from my family, from my school, from my even sports ground. That is the way we grow. Another major challenges right now I'm observing as we work in academy, especially I try to take care of the students and the youth community, what's going on, what they are doing. I know there are many audience, they are observing our show. But fact is that when the technology come, I asked my people, hey, what's going on in the playing ground? They said, hey, there is no people, no young people. They are not playing right now. They are with social media, with Facebook, with this and that. They are more integrated with technology and these things. What do you think? From my personal views, I learn a lot from big family because I'm from a very big family. I can remember we have 30 family members. Second things, I learn a lot from schools and the sports ground, especially leadership, especially how to respect people. Do you think that if we depend too much on technology, especially I am worried about youth, especially I'm worried about young people, uh, they may lost their innovations, creativity, leadership, caring about society, caring about people. What do you think?
Well, you're talking about one of the paradoxes we're working with today through looking at how human capital works as an asset. Marshall says human capital is the greatest asset of a company. I agree with him, but I also think data is the greatest asset of a company because it's non-perishable when you think about data. Um, and as kids are playing games, as kids are connected to their computer, in some of the games they actually are learning collaborative skills. In some of the games, they're actually beginning to don't tell them, but they're applying physics, they're applying geometry, they're applying strategy, and all of these elements to play their games. If they play games like blackjack, they're being taught math and probability theory and stuff like that. So there is a place for an electronic part of gaming. On the other hand, the electronic part also has great applicability. We're seeing a explosive growth in drones. Some are becoming more autonomous, but most of them, the good gamers, are also the best people for controlling drones because they've honed that as part of being on their PlayStation or whichever gaming device they're using. But it takes more. I tell parents when I'm asked the question, which you just asked, is let them have computer time, but also have them do physical interaction times. My go-to for that is let them play on sports teams. If they're on a field with 9 other people playing football, they're learning collaborative skills, they're learning leadership skills, they're learning how to look ahead because you want to be where the ball's going, not where it's been. And that is a skill that can complement it too. The other place I would go back to again, Sharif, with your question, is they have to understand it's a time of lifelong learning. And they need to put that in their mix. And I can tell you, one of the persons here in Austin who I'm working more closely with right now is running into a human-centric process challenges in their company, and she's a developer. These others are developers, but their worldview of how do you work as in a process? How do you do collaborative tasks is so very different because one is older, several are in the middle, a couple are younger, and how they view those tasks are based upon the generations they're in. Now, we're at a unique inflection point that's going to get worse in this way, and worse is a good thing in this example. We have 5 generations in the workforce today. Most of those generations receive information using different modes. Most of them like to interact in different ways. I can tell you, trying to get a teenager to talk with you on the phone today is almost impossible. But yes, they will answer my messaging. And so that generational impact, particularly as regenerative healthcare continues to push out this, where we will have 6, 7, 8 generations in the workforce. And that's going to be one that people have to understand and interact with outside of what they can do just on their smart device or on their more traditional computer.
Thank you. Mr. Marshall.
Yeah, I have actually a personal anecdote to share that David reminded me of. I'm blessed with 4 grandchildren. Of course, we have 3 grandsons and a new granddaughter who's the princess, and everybody bows down to her. Obviously, she's the queen and runs the family. But I have a 10-year-old grandson who's our first grandson, and when he was 3, I was astonished. My son, who's a banker and was using an iPad, and this 3-year-old grandson goes up to him and he says, "Dad, you're not using the iPad correctly." He takes it out of his hand and he starts using it for him and getting him what he needs. That blew me away. A 3-year-old. Now he's 10, and of course he's way beyond the capability of the 3-year-old. So I think what David is referring to intergeneration and talking about 5 generations in the workforce. I think we need to be mindful of that, and I agree with David that we need to embrace these people. I agree that data is a very important asset, but ultimately that data, the asset of data, which is important to any corporation or any entity, whether it's an NGO or a for-profit entity, it's all for the benefit of humankind. We're not doing it for the robots' benefits. We're doing it for us, and we're doing it for everybody out there that's listening in here. That's the ultimate benefit. So if we can improve people's quality of lives, if we can improve their environment that they're working in, and where cobotics plays a role in that, is that, yes, we need to integrate that. And there's going to be other technologies like we're doing that will be integrated with the cobotics, such as the artificial intelligence, such as the supply chain mechanics that are going on with that, keeping track of inventory. It's all tied in. It's going to become an integrated world. We need to learn, in my humble opinion, how to integrate technology with humanity. If we don't do that, we're just going to create more consternation and more frustration amongst young people. And I think I don't think that's where we're heading. I see it in my grandchildren. They're already embracing technology because they grew up with it. Me, I'm an old guy. So I was involved in computers when we had SPSS data structures where you had to fill out computer cards and program the computer that way. Now I've integrated a cell phone. I'm on an iPhone right now with everybody on this program. And true, I did get cut off, but that's technology. But technology is not flawless, and neither are humans. But ultimately, we need to learn how to integrate these technologies together with humanity, and remember and keep in mind that the ultimate goal is the improvement of humanity, better quality of life, and an economic value that brings people lives that they can enjoy and participate in with other people, and also hopefully save other people's lives. So that's my take.
Excellent. Thank you. This is really, really great session. 2 experienced men from 2 different industries. It's really valuable content. I request all of our audience, you should share like with your government, with your young people, with your entrepreneurs, because this is very valuable for your development, because they have huge experience from around the world, so their experience is priceless. So everybody can learn from their experience. So thank you everyone for joining today's sessions. I directly want to go for the concluding remarks. Professor David Smith, what's your concluding remarks?
Do not be afraid of cobots. Embrace them. Just like we embraced having animals pull our plows, to having tractors pull and calculate those, we saw dramatic enhancements in the ability to produce food. If we had not done those, we could not support where we are today. So in instances, change is good because the world is changing. But because the world is changing, we need to continue to keep up with it with our skills and our capabilities and our competencies. Um, Cobots is a perfect example of how humans and technology are getting closer and closer to each other. What is going to really enhance even more the growth of cobots is the amount of sensors we've seen being placed in the world, particularly Internet of Things sensors. And these Internet of Things sensors are interacting with the digital side of the cobots and providing information to them that I, as a human being, would not be able to see just using my five senses. And so that is an enhancement where the collaboration of the cobot is what's important here. Humans still have the domain knowledge. Humans still have the domain knowledge that makes artificial intelligence happen, but it's supplemented by the use of sensors. And an example, just for those of you who are watching today, that's usually not the case on your shows, but all three of us have glasses on. And that is a piece of technology that is enhancing our ability to do stuff. And cobots are just like me wearing glasses, is they will enhance our ability, but we have to continually learn to be able to deal with the next generation. And we have to innovate to take cobots and do things with them in different industries and different domains that we haven't done before. So a lot of opportunities, but the basis is continue to learn, continue to experiment, continue to innovate, continue to be entrepreneurs. That's the key thing as we see this going forward.
Thank you. Thank you for your excellent comment. Mr. Marshall, what's your concluding remarks today?
Well, first of all, I want to thank you, Sharif, and also David. David Smith is very observant. He saw that we all three are wearing glasses. By the way, mine are trifocals, and they turn dark in the sun. So advancement in technology, right? But David is absolutely right. I love being on the show with David because he has observations and knowledge that a lot of other people don't always see at firsthand. So he's a very observant person and very knowledgeable. So it's an honor to be on the show with you as well as Sharif, and thank you. My concluding remarks are pretty simple. I like David, embrace cobotics, embrace technology, make it work for humanity. Do not be afraid. Take the opportunity to learn, and I agree that at the end of the day, if we embrace this technology, people around the world, whether they're in developed countries or non-developed countries, can embrace this technology and use it to the benefit of their populations, their communities, and their governments. So I think this is something that also requires, believe it or not, an embrace of a democratic ideal, meaning that people need free thought. They can't be told what to think. Otherwise, we're just going to all become robots, and that's not what we are. We're humans, and as David pointed out, the humans embrace the technology, but at the same time, they are managing the process. And yes, AI may come down and take more of that away, but ultimately it's humans that have the ultimate decision. And so I just want to thank everybody being on this broadcast and sharing this information. And if anybody wants to reach out to any of us, please feel free to do so. Sharif, thank you again. And David, thank you again for participating in this.
Yes. And another things, both of you are entrepreneurs. I always say developing nations has lot of problem. They need lot of solution, and they need entrepreneur like you. Thank you, Professor David Smith. Thank you, Mr. Marshall. Hopefully soon we will meet in offline. Thank
Thank
you.
you.
Thank you.
Cheers.
Bye bye. Take care. Yes.
Bye-bye.
Bye.